Okay, class, it is time to learn how to graph point by point with some rigid transformations. I would really like for you to have a bunch of colors. So we're going to do some colorful graphs here. And the first one is going to be the basic one. So I'm going to be doing this one in black. It's the basic. We're going to study it and we're going to learn the growth pattern for a parabola. A basic x squared parabola, if we plug in 0, we get 0. If we plug in 1, 1 squared is 1, as well as negative 1. 2 squared would be 4. 3 squared would be 9. Okay, I want to see as many points that can fit to get to the edge of the graph paper. We're going to go ahead and draw the parabola like this. This is your basic x squared. Make sure you use lots of different colors so that when I check your notes, this one is clearly x squared. Okay, we're going to study this here for a second now, and we're going to try to understand the growth pattern of a parabola. So he starts at the origin, and to get from the first point to this next point, we go over 1 and we go up 1. To get to the next point, we're going to go over 1 and up 1, 2, 3. To get to the next point, it's over 1 and up how many boxes? Up 5. If we continue this pattern, it would be over 1, up 7, over 1, up 9. So what you have to remember for a parabola is he grows up at a growth rate of 1, 3, 5, 7, 9 from point to point to point. Okay, now the next one, I'm going to change colors here. I'm going to do it with my green pen. And I can't help but notice that he has a negative out in front. Is that negative getting squared? No. That negative means reflection over the x-axis. So if I take this parabola and I reflect over the x-axis, he's going to be opening down. Okay? So we're going to use the same growth pattern, but instead of going up, we're going to be going down. So here we go. Over 1, down 1. Over 1, down 1, 2, 3. A point on the right, a point on the left. Over 1, down 5. Over 1, down 5. Since I've color-coded them, I don't really have to label them, but if you'd like to be extra specific, you can go ahead and say that this is f of x being negative x squared. But the green pen goes with the green one. Okay, let's do another parabola. This time we're going to transform him by doing x squared plus 3. And I need to ask you, is that 3 getting squared? No, it's outside. It's after the function. When you're after the function, that means you shift up 3 units. Okay? So where is the vertex of the parabola going to start if it's not at the origin? It's up 1, 2, 3. Here's where the parabola is going to start. And now how does this grow? Well, let's study our growth chart here. Over 1, up 1 on either side. Over 1, up 1, 2, 3. And then over 1, up 5, I can't fit on the graph paper. 1, 2, 3, 4, 5 would be way out here. So what I don't want people doing is suddenly veering off. You have to stay within these boxes right here and not get to the next line because you told me that it's not going to fit, so don't touch the next number. The purple parabola is completely within the basic black one. It's just shifted up. Okay, and the fourth and final transformation here on a parabola, oh, there's two things. This 4 is inside the function. That's kind of like the weirdo. That always works opposite of what I think. That means go 4 to the right. And which way are we going to go for that 2 since it's outside? That's going to be a vertical translation, up 2 units. So let's go 4 to the right, up 2, and we'll start our parabola there. Okay, here we go for the last time. Over 1, up 1. Over 1, up 3. Over 1, up 5. 5 looks like he might be one box off the graph paper. I'm going to plot that point so I have something to aim for. And here is a parabola, point by point. There's not really a whole lot of work, so for this test and this chapter, I'm going to be grading your points, point by point. A sloppily drawn, sketchy parabola is just not going to cut it. Okay, it's time to go study x cubed. So let's go down here and look at the growth pattern for a cubic. Okay, I'll switch to my black pen for the basic one again. The basic cubic, if I take 0 and cube it, I will get 0. 1 cubed is 1, but negative 1 cubed is a negative. 2 cubed is 8. 5, 6, 7, 8, way up there. If you notice, these graphs have darker lines at the 5, so you can count quickly. So we got to go 5, 6, 7, negative 8. I don't think we can hit the next one. So this is a tall, skinny cubic. Okay, let's go ahead and write our growth chart here over and up. Okay, so what you need to do tonight is spend some time studying these growth charts. The basic cubic starts at the origin, goes over 1 and up 1 to get from the first point to the second point. Now, how do we get to that next point? Well, we go over 1 clearly, and I'm at 1, and I got to get all the way up to 8. So how many up would that be? Yeah, 7. Okay? And sometimes we're going to need this third one right here. Let's see. If I take 3 and cube it, that would put me all the way up 27. I'm at 8. To get from 8 to 27, can anyone figure out the next number? I think we're looking at a 19. Okay, so what you need to study tonight is 1, 7, 19 for x cubed. All right, let's do our next one. The next example has a negative out in front, negative x cubed. If the negative is there, that means reflection. Since the negative is not getting cubed, it's out in front, that's going to be the x-axis. So what's going to happen? Everybody above the x-axis is going to get flipped down here. Everybody down here is going to get flipped up there. We're going to have the same growth chart though. So it's going to go over 1, down 1. It's going to go over 1, down 7. Okay, so here is half of the cubic that got reflected down, and this part of the cubic needs to get reflected up. And then I usually like to ask students at this point, are these parabolas? And the answer is no, because these are not the same growth chart as a parabola. This is a cubic. He's a little skinnier because he's cubic, he grows faster. Okay, number 3. I've got x cubed minus 4. That 4 wants me to shift down, 4 units down. So your starting point, which used to be on the origin, is now 1, 2, 3, 4 units down. Are there any other transformations? Nope, that's the only one. So we're going to go ahead and start our growth chart. Over 1, up and down 1. Over 1, up 7. I don't think I can fit 7 going down here. So what we need to do is exit the graph paper before we get to the next line, that next value, because I don't have a point on the graph paper. Over here, I'm going to want to make sure I hit this point, but I can't fit 19, so we're just going to quickly exit, staying within those 2 tick marks. And the final one here has 2 transformations. I'm noticing a 4 inside getting cubed. That means 4 to the right and 2 units up. Okay, here we go. 4 to the right, 2 up, and we'll do the growth chart for a cubic. Okay, ready class? Here we go. Over 1 up, 1. Over 1 up, 7. Oh, I think that fits the very top of the graph paper. Over here, 7 is 1, 2, 3, 4, 5, 6, 7. There we go. Nice cubic. Now, just because this is the last point that fits does not mean it's the last point on the cubic. You need to make sure that you draw your arrows. I'm going to be grading arrows, points, and nicely drawn graphs. Okay, let's turn the page. And now we have our absolute value graph. The absolute value of a number becomes positive. So the absolute value of 1 is a 1, 2 is a 2, 3 is a 3, 4 is a... Now don't be lazy. Come on. Let's get all the way to 10, 10. The absolute value of negatives are also positive. So all of the points all the way through negative 10, 10 are on this graph. And then we're going to take out our ruler or our IDs and we're going to go ahead and draw some nice straight absolute value graphs with arrows. Now let's study this growth chart here for a second. Over 1 up, 1. Over 1 up, 1. Over 1 up, 1. Well, this is the easiest growth chart in the world. His pattern is simply 1, 1, 1, 1, 1, 1. It'll get a little more exciting tomorrow when we start stretching them. Okay, number 2, I notice a negative. That means reflection, and when it's out in front of the function, that means we're going to reflect over the x-axis. If I take a function, reflect over x-axis, it's going to be opening downwards. So that means we've got the points going down here like this, over 1, down 1, over 1, down 1, all the way through negative 10, 10. Make sure you put all your points, nice straight lines. Let's use a ruler or an ID if you have one handy, and don't forget the arrows. Okay, the next one, I can't help but notice that there are 2 transformations. We have to go 5 to the left, and we have to go 1 unit down. Is this absolute value graph getting reflected? No, I don't see any reflections. So we just go 5 left, 1 down, and there's your starting point. All right, we're going to grow up. Over 1, up 1, over 1, up 1, over 1, up 1. So this branch is completely parallel to the basic branch, and we have our absolute value graph here. Absolute value graph. Okay. And for the third and final one, I've saved my best color for this one. I'm going to go ahead and put a star by this one because this one is extra fun. Okay, we're not ready yet. Something needs to happen inside here so we can get it ready. Let's go ahead and rearrange this. F of x is equal to the absolute value of negative x plus 3. So the first thing we'll do is we'll do some work rearranging. And it's not ready yet. We have to also get that x alone. So if there's a negative by it, what I want you to do is factor the negative out, not out of the absolute value. You're going to factor it out, and you're going to use parentheses inside the absolute value, which gives us a positive x, a nice x all alone, minus 3. If you don't rearrange and factor, you're going to get something wrong here with the shifting. And we have to do these in order. So step 1, the first thing I see is a reflection, and this is inside the function, so that's going to be the y-axis. Step 2, we're going to shift 3 units to the right, and step 3, we're going to shift 3 units up. So I'm going to go ahead and take my hand here. If this is my absolute value graph, and I have to reflect him over the y-axis, what essentially happens to him if I reflect over y-axis? Not a whole lot. A reflection over the y-axis for this function looks the same. Okay, so step 1's pretty easy. Then we have to go 3 to the right and 3 up. So we're going to start right there. We're growing up, and I've done my 3 transformations in order. So this branch is going to be real easy. It's going to be exactly on top of the basic. And then this one is going to be going up, over 1, up 1, over 1, up 1, over 1, up 1. Absolute value graphs. I know they're so easy to do. Just make sure you be careful and plot all the points. Okay, it's time for the last function. I'm only going to be asking you to graph point by point these 4 functions. Okay, the first one is the square root. So let's go ahead and take the square root of 0, which gives us a 0. The square root of 1 is 1. The square root of 2, oh, that's too icky. Let's not do that. Let's do the square root of 4, because that's easy. That's 2. So I'm going to pick nice numbers, perfect square numbers. The next one I'll plug in is 9, because the square root of 9 is a 3. So this is what a square root function looks like. He looks like a shooting star. He's curvy. He's half a parabola. And let's go ahead and write down the growth pattern of a square root. Okay, he starts at the origin, and he goes over 1, up 1. Okay, that's the same. They all start like that. To get from his second point to his third point, oh, he's growing over. This is different. We're going to go up 1, but we're going to grow over 3. So it's 3, 1. To get to that next point, we're going to go up 1 again, but this time we're going to go over 5. So if you study this, this should be very familiar. The square root function is directly related to the parabola function, and it's 1, 3, 5, 7, 9. You got it. Okay? But instead of growing up, he grows over. Okay, let's do another couple things here. The next one has a negative out in front, so that is going to be a reflection over the x-axis. So if I take a look at this graph and I study this as the x-axis, my graph is going to be reflected over that x-axis down into quadrant 4. Okay, quadrant 4 is going to be looking like this. Down 1, right 1. Down 1, right 3. Down 1, to the right 5. The 2 of these should make a very nice parabola. Okay, number 3. I see a negative inside the radical. That is going to be a reflection over the y-axis. So if I take a look at the basic parabola right here, and I reflect him over the y-axis, that means he's going to be going into quadrant 2. Okay, so he's going to grow to the left. Up 1, over 1. Up 1, over 3. Up 1, over 5. There we go. Parabola growing to the left. Oh, we've got one here that has 2 transformations. A negative outside means that we have to reflect over the x-axis. And this 3 inside means we need to go 3 to the left. Okay, reflect over x-axis is going to look like my green one. But then I also have to make sure that he gets shifted 3 to the left. So take this green one and go 1, 2, 3 to the left. He's going to start right here, but he's going to grow down to the right. Down 1, right 1. Down 1, right 3. Down 1, right 5. There he is. He's never going to surpass the green one. He's just going to kind of keep growing right along next to him. Okay, the last one right here. Once again, I say my best color for the last one. I put a star by him because this one is not ready yet. So what we're going to do is take f of x and rearrange the inside. Negative x plus 4. Don't forget, we also have a plus 4 outside that square root function. And this is still not ready because we need to factor a negative out, not out of the radical, just away from the x. So we're going to put some parentheses. We have a quantity under that radical, which gives us x minus 4. Now there's 3 steps. Make sure we do them in order. Step 1 is going to be to reflect over the y-axis. Step 2 is we're going to shift 4 units to the right. Those X files, little opposite weird stuff happening. The third step is we're going to shift 4 units up. If you'd like to be extra fancy, you could say a vertical translation 4 units up. Most people just say 4 up, but that would be technically very correct. Okay, reflecting over y-axis looks like my blue graph here. But we also have to go 4 to the right and 4 up. So we're starting here, we're growing up to the left. Okay, here we go. Up 1, left 1. Up 1, left 3. Up 1, left 5. I don't think I can fit 7. So here we go. When graphs start to get this complex, I always suggest testing to make sure we're doing this correct. So I'm going to take a point, not the end point, because what if it's going the other way and you don't really tell? But take a point somewhere along, like maybe this one here, 0, 6. And I'm going to see if that is correct for this equation. So the square root of 4 minus 0, radical 4 is 2. 2 plus 4 is 6. Did we get a 6? Yes, it checks. Can you graph the parabola, the cubic, the absolute value, and the square root function point by point? Okay? Good luck, and I'll see you soon.